Hello, welcome to the video lesson for, or video notes for lesson 6-10. Convert equations to slope-intercept form or standard form. This begins on page 56 in your notes from your binder. Let's take a look at the learning targets first. So I can convert equations to slope-intercept form, which is y equals mx plus b. And I can convert equations to standard form, ax plus by equals c. Now, converting these equations is a valuable skill for doing some of the solving that we want to do. Whether you want to graph an equation or solve it by substitution or elimination, being able to convert these equations can help you do whatever strategy you're trying to use. Alright, so let's go ahead and take a look at some of the examples. The first group, we're going to convert the equations to slope-intercept form. So, just so we're aware of what we're trying to accomplish, write down y equals mx plus b. The key here is we want to isolate y. We want to get y all by itself. And everything else needs to be on the other side of the equal sign. Even if there isn't a slope or if there isn't a y-intercept, we want to get everything over here so that y is by itself. So when I look at the first equation, I see y plus 3 equals negative 1/3 x. And what I'm going to do is, I'm going to draw my line through my equal sign, because this is essentially doing inverse operations, the way we solve equations. And the only thing is, when we get to the end, we're not going to have a solution, we're just going to have a different form of the equation. So to undo adding 3, we're going to subtract 3. And we're going to do that to both sides. Now this is not a like term, so we won't be able to combine it, so we get y equals negative 1/3x minus 3. You know what? I just remembered something. Let's go back up to the top, because I want you to write down something very important. I want you to write down to remember don't need that dot right there, that adding a negative is really subtraction, and subtracting a negative is really adding. And the reason why I want you to write this down and to draw your attention to that, because some of the solving we're about to do involves changing something from subtracting a negative to adding, or adding a negative to subtracting, okay? Or the other way around, so that we can put the equation in the right form. Alright, so let's go back to what we were doing. Okay, so we have the first one that we were working on, and we got it to y equals negative 1/3 x minus 3, and we have y isolated, so we are actually all done. I can't do anything more with the right side of the equation. They're not like terms, so they can't be combined. Okay, the next one, 5y equals 25x minus 15. So you probably recognize there's a 5 there. So we want to undo that multiplication by dividing. Now whatever we do on one side, we do it on the other. Instead of putting one big line and a 5 under it, I'm actually going to put a line under each term, because I basically want to divide everything by 5. So watch what happens. 5y divided by 5 is y, so I got my y isolated, equals 25x divided by 5 is 5x, and minus 15 divided by 5 is negative or minus 3. And we're done with the second one. Third one, negative 2y minus 6x equals 10. Alright, so the first step I'm going to do is I want to get this minus 6x, I want to undo that and get it over to the other side. So I'll add 6x. Now if you want to write this, so over here it zeroes out and we still have negative 2y, we're almost done. If you want to write this 10 plus 6x, that's fine. But remember, addition is commutative, so I can switch it around. 6x plus 10 is basically the same thing. And I want to try to keep it in this mx plus b form, so I'll put the term with the x first. Now I'm going to divide everything by negative 2. And I get y equals negative 3x. Now you can either write plus negative 5 or y equals negative 3x. Remember what we set up above, adding a negative is really subtracting. Either of these answers is correct. Okay, now we're going to convert equations to standard form. So that's going to be ax plus by equals c. So we're going to have some number in front of x, some number in front of y equals some number. Okay, so the first one. Now we have the 6y is already on the left side. So we want to get this x over there, and we see a minus sign in front of it. So to undo it, we're going to add x to both sides. So I have 6y plus x equals 3. Hey, look at that. I'm all set. I don't need to do anything else. It's already in the ax. Well, I could switch it. Let's switch it around. Or x plus 6y equals 3. So I have ax, or 1x, plus by equals c. So it's in the right form. So either of these answers is correct. The next one. Okay, you'll notice we have the term that's just a number next to the y, or on this side, and the term with the x is over here, so we got to switch those around. So let me switch the colors here. Let's undo that adding an 8 by subtracting an 8 from both sides. Now we can't do 5x minus 8 because they're not like terms. So I'm going to write 9y equals 5x minus 8. Now to get the x over on the other side, I'm going to subtract it from both sides. And you get 9y minus 5x equals negative 8. Now this would actually be okay. Let me scooch this up a little bit. But I think, remember, we can treat subtraction like adding a negative. And now because it's adding, I can switch the order around. Remember, commutative. So I have negative 5x plus 9y equals negative 8. If you stop up at this 9y plus minus 5x equals negative 8, that would be okay. But I think this fits the standard form a little better. And the last one, 7y equals 6x. Okay, so we got to get this 6x over here. How do we do that? Well, subtract it from both sides. Don't divide, subtract. Okay, so 7y minus 6x. What's over here? Well, 6x minus 6x, that's 0. So, again, we have a subtraction situation. If I want to put the term with the x in front, I'll treat it like I'm adding a negative. And so I get negative 6x plus 7y equals 0. And that will be my final answer. Okay, so you can see you're using your algebra skills to move terms from one side of the equation to the other. It's just simply putting it in the right form. It takes a little practice. So, good news. On the next page, page 57, we have some examples here. Write the given equations in slope-intercept form. The list of correct equations is listed at the bottom of the page. Cross out the answers as you solve the equations to reveal a hidden message. I'm going to do one of these just to demonstrate. By the way, they tell us it needs to be in slope-intercept form. So all of these need to be y equals mx plus b. So the one I'm going to do is this negative 6y equals x. So I divide both sides by negative 6. And I get y is equal to x over negative 6. So when I'm looking through here, I don't actually see one that looks exactly like that. However, there is one that is equivalent, and that's the one that is u. Y equals x over negative 6 is the same as y equals negative x over positive 6. Either way, if there's a negative sign in the numerator or the denominator, the entire fraction is negative. So cross out u. Now you have 5 more to do, and then that will reveal the hidden message. For everybody that gets it correct and has all the work to support it, I'll give you a point on your scoreboard. Good luck. I'll see you in math.